Now that we know what's happening in the core of a star, where you have tritium and deuterium coming together to create a helium atom, kicking out this extra neutron, here's your helium, and a whole bunch of energy, because this weighs less than what you start with, and that mass is converted into energy. What is that energy? They are very, very high energy electromagnetic waves. We call those photons. They are photons that are in the gamma ray part of the spectrum. What happens to them from there? We're going to find out. In order to do that, I'm going to tell you a story. This story is titled Journey from the Center of the Sun. Now, we don't often stop to think about the journey of a ray of light from the core of the sun, where it's made all the way to Earth's surface, where it might slam into us when we sunbathe sometimes, maybe even hitting us in unfortunate places. In the core of a star, for our sun, about 15 million degrees Kelvin, hydrogen nuclei reach high enough speeds to overcome their natural positive repulsion, and they collide. Taking out all those steps that we learned the other day, the sun simply says hydrogen turns into helium and energy. That energy is light, photons. There's also some other things like neutrinos, but we're focusing on the photons right now. Every time a helium nucleus is made, particles of light called photons are made, and they're powerful enough to be gamma rays, a form of light with the highest energy for which we have a classification. These are the ones that are going to give you cancer after a nuclear explosion. Photons are born traveling at the speed of light because they are light. That's the only speed that they can go. And then they unwittingly begin their trip out of the sun. That speed of light is 186,000 miles per second. An undisturbed photon always goes in a straight line, but if something gets in the way, the photon can either be scattered, absorbed, and re-emitted. Each of these fates can result in the photon being cast in a different direction and with a different energy, a lesser energy, something in the X-ray or maybe even visible light spectrum. Given how dense the sun is, each straight line trip lasts for 1/30 billionth of a second, or about 1 centimeter of travel time for that photon of light. After 1 centimeter, that photon of light is going to interact either with an electron or some other particle in the core of the sun. With constant new paths going outwards, sideways, backwards, how does an aimlessly wandering photon ever make it out of the sun? Remember, it's being re-emitted, and it can be re-emitted in any direction with any amount of energy. A clue lies with this poor guy. Let's actually watch the video for a second. Yeah. So with a step the size of only 1 centimeter, a photon is going to need to take 5 sextillion steps to randomly walk forward, back, left, right, up, down, the 70 billion centimeters from the center of the sun to the surface. The total linear distance would be about 150,000 light years. And because a photon travels at the speed of light, that 150,000 light years will take about 150,000 years. Remember, though, that the outer portion of the star moves by convection, those elevators rising to the top, making those granules on the surface. Not only do they rise up, but they also can sink back down. So unbeknownst to our randomly walking photon, the blob in which they are residing can randomly and very quickly sink back down tens of thousands of kilometers back towards the center of the sun, undoing possibly thousands of years of random movement. Convection can bring them closer up to the top, but just as often, it's going to bring them farther down. Unfortunately, the structure of the sun, where most of the mass is at the core, and it gets much less dense as you move out, and that matter convects as you get to those outer layers, means that the total trip for a random photon can last up to 1 million years, from the time it's created to when it gets to the surface of the sun. If the photon could have just gone in a straight line without randomly walking around, it would have taken 2.5 seconds. Instead, it's taking up to 1 million years. Only about 1 of every 500 million photons that come out of the surface of the sun are headed in the direction of Earth. And once the photons reach the surface, they only take about 8 minutes, about 480 seconds, to go from the surface of the sun all the way to planet Earth. Keep in mind that heroic adventures throughout the sun are best taken by photons. If you guys were to go on that trip, you'd be instantly vaporized, you'd be instantly crushed, and every electron would be torn from every one of your atoms. Just know that when you sunbathe, though, you should do it with the full respect of that huge journey that the photon went on, taking millions of years to reach you and give you your suntan.
Light. It's so central to life that we don't often give it a second thought. But how light gets from there to here turns out to be an incredible story. The energy created in the fusion process is carried out of the core by particles of light and heat called photons. They are what bring the warming rays of the sun to Earth. To reach our planet, these glowing travelers from our nearest star must first take a long, winding road through all the layers of the sun, like Dante journeying through the levels of hell. First, a photon enters the 185,000-mile-thick radiative zone. The region is so densely packed that the photon constantly bumps into other particles, like hydrogen and helium atoms. It struggles outward in a chaotic zigzag pattern that scientists call the random walk.
A photon can't escape without interacting over and over and over and over again, getting absorbed by atoms and re-emitted, and it can be absorbed and re-emitted millions of times. As the density decreases, as you get further up in the sun, it becomes easier, and the collisions and the interactions are less.
When it finally reaches to within 130,000 miles of the surface, the photon enters the convective zone, and the pace suddenly quickens. It's carried upwards by a kind of boiling, riding along in huge columns of gas at hundreds of miles an hour, taking only 10 days to emerge on the solar surface. The incredible journey is almost over as the photon lifts off through the wispy gases of the solar atmosphere. From there, it takes only 8 minutes for it to zip across 93 million miles of space to our planet. Incredibly, by the time sunlight actually reaches Earth, it's already been in existence for hundreds of thousands, if not millions of years.
Go back to your science journal real quick and answer this question.